across, about 100 kilometers across, and beautiful, the 11,000-foot tall mountains ringing, and all these lovely features on the moon are going to get swallowed up. What's really happening, folks, is that if you were on the moon right now, standing, let's say, on the middle of it, you'd see about half of the sun blocked off by a piece of the Earth. But if you were on the edge of the moon right now, where it looks like nothing's hitting it, what's really striking the moon right now is a little bit of sun. The sun is 98%, let us say, blocked out by the Earth. So only a little bit of sunlight is hitting that section. Therefore, even though we have a little over 2 minutes to go before the official umbral eclipse, which is when 100% of that section of the moon is blocked off by Earth and gets no sunlight at all, except for some weird stuff from our umbral shadow that we'll talk about later. Nonetheless, you can see there's a gradation. It's not as simple as a sharp line between the eclipse and no eclipse. It's really the line on the moon between, on the upper right, we're looking at a part where perhaps only 1% of the sun is blocked off. Almost full sunlight is hitting that. On the lower left of the moon in this view, 99% of the sun is blocked off. So it's a gradation in actuality, and that's why it looks that way. I love it. Don't you love this?
And this is one of the cool, weird things about these lunar eclipses. It's exactly what you're saying, Bob. It's a diffuse line. It's not like the Terminator. You can't see craters with their edges and their terrace walls just peeking up above the darkness. It's a very strange view. And actually, if I have a look back now, literally in the couple of minutes I've been talking to you now, that edge has dimmed and it looks nothing like a normal phase. So if you're watching the show, go out, pop your head out the window now, because this is such an unusual thing to see. This particularly shading that you're talking about, Bob.
That's right. And drag the kids out. If you've got kids, and I know somebody who almost has a kid around here, because his wife is due any minute now, is why I shouldn't be spilling the beans about that. Yeah, drag them, wake them up. I know in much of America and certainly in Europe, it's the wee hours of the morning, or at least it's after sunset, and the kids have to go to school tomorrow. What the heck? Wake them up. They'll always remember this moment when their parents dragged them out of bed, took them outside, and said, look at that. That's our moon going into Earth's shadow. You can even explain that, hey, you and I cast a shadow when we walk down the street. There's our planet's shadow. And the moon, which is the only object in the known universe that travels its own width per hour. I mean, crazy. 2,160 miles across. Its average speed is 2,280 miles per hour. It goes its own width per hour. And so it's moving now toward the lower left in its actual orbit around Earth. This isn't some optical illusion. We're seeing its orbital motion as it plunges into Earth's shadow.
Isn't that remarkable? And actually, we're literally approaching the second that we begin the moment when it's going into the umbra that we mentioned just a few minutes ago. And if you look, when we were talking about Aristarchus, in just this short time, has almost completely disappeared as it heads into that umbral shadow. It's amazing to watch right before your eyes.
Yes. Some people are a little, I won't say appalled, but a little surprised that the edge of the shadow is not sharp. Now, if you've ever been to a total solar eclipse, very few have, you see the sharp edge of the moon's shadow blocking out the sun, and it's razor-sharp edges and very fine bits of detail. Not here, because, again, the edge of the Earth's shadow is a fuzzy thing. It has to be, because it's really the borderline between where the moon is 99% eclipsed and where it's 100% eclipsed. And you go another 100 miles away from that on the moon's surface, and it's 98, 97, 96% eclipsed. So expect that as this eclipse, now that the umbral eclipse is underway. Umbral eclipse means that now in the upper left, if you're standing on the moon, you have no sun at all. Only Earth's shadow is striking the moon. And so the official partial eclipse, the umbral eclipse, has begun.
Yeah, it's a great moment. It's extraordinary, not just to see in the live pictures, but you can go out now and actually see this moment as it's really starting to descend into that darkness. You've actually now properly lost the top left corner, haven't we, of the moon there?
Yes, yes. People wonder, how does this differ from the phases of the moon? I'm always surprised that there's a number of people who are going to
We
be
need
watching for that.
We need a name for it, don't we, Bob? We were discussing that the other day. We need a name like we have when a solar eclipse. We have that beautiful moment, the diamond ring and Bailey's beads, which herald the beginning of totality. I think maybe some slew viewers can give their opinions, ideas on the hashtag.
The hemogenesis. How's that?
Yes, I like it. I like it.
Hemogenesis. We're waiting for, well, let's be the first to start using that. We're waiting for the hemogenesis, the moment when the moon turns red, when the shadow turns red. Meantime, look at that moon continuing to rush into the shadow. The speed of the moon, to about 2,280 miles per hour. Not terribly fast as such things go. Earth travels at 66,000 miles per hour. If you're in the part of the world that uses the metric system, which is essentially everywhere except for the United States, think of Earth going about 100,000 kilometers per hour, a little over that, and the moon moving a mere 3,700 kilometers per hour, much slower, but it's fast enough to move its own width per hour, and then that means that in 1 hour it'll go from having just touched the moon's edge to being fully immersed. And if you look at the eclipse timings, sure enough, this partial eclipse began at, I'll use Eastern time for the moment, at about 9:07, and the total part begins at 10:11, just 1 hour and 4 minutes later. So it all makes sense. It's great for things to make sense in the universe. Certainly there's enough chaos here on Earth, and that's one of the great things about astronomy. It's all very clockwork, tick-tock, logical, sensible. You can count on it.
Yeah, absolutely can. That's the beauty of it.
So weird things about the moon. You know, in this segment, let's just each give a favorite strange thing about the moon, since the eclipse is so odd. I'll go first. I think my favorite thing is that when the moon is struck by a large meteor, or when it got hit by a descent stage, an unused descent stage in the Apollo mission, it started shaking like a giant gong. It rang for as much as 2.5 hours without stopping. On Earth, when we get clobbered, our vibrations dampen out in just a minute or two at most. But on the moon, it keeps going wah, 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 like a giant gong, and rings, shakes, vibrates for hours, which seems to indicate it has, unlike Earth with our liquid molten core, although the solid, the very middle of the Earth is solid, the moon must have a solid crystalline core that translates vibrations back and forth, and the whole thing rings like a bell. I love that. Hi, I'm back. This is Bob Urban, and this is SLU for our great lunar total eclipse. And right now I'd like to talk to you about whether the world is coming to an end, because there's a lot of web traffic and a lot of reasons that people think it is. And it is a pretty amazing night, what's happening tonight. I mean, think about it. It's the harvest moon and the closest approach of the moon of the entire year. At the moment the eclipse is happening, the moon is turning color. It's a tetrad. There's Bible references that are involved. I mean, there's all sorts of things that are making some people afraid of what's going on. So let's talk about that. You know, it's not just moons that cause it. For some reason in the astronomy world, we have all sorts of end-of-the-world Armageddon type experiences almost every year. Some people think there's a hidden planet named Nibiru that's on a collision course and it's going to collide today during the eclipse. Others think it's later this year or next year, but you'll see a lot on the web about that. In truth, no, NASA and the world's astronomers are not hiding some cataclysm. I've been connected with astronomy all my life, and I can tell you that these are blabbermouths. Astronomers would never keep anything hidden. They couldn't if there was something actually happening. Also, if there's a planet really on a collision course with us, it would already be noticeable, because at this point it would be close enough to be seen in the sky by everyone. So that's not happening, and the yearly asteroids that come close to us are comets that are visible every few years, and all of these end-of-the-world things. I mean, haven't we learned by now? They don't happen. But this event is a little different, because this lunar eclipse is a confluence of so many different things happening at once. It's eclipse moon. You should go to the emergency room, because that's not a good sign. The real drama comes in because that illusion, that term blood moon, feeds into some Bible passages, such as Revelations 6:12, where it says, "And I beheld when he had opened the sixth seal, and lo, there was a great earthquake, and the sun became black as sackcloth of hair, and the moon became as blood." Or Joel 2:31, which says, "The sun shall be turned into darkness, and the moon into blood, before the great and the terrible day of the Lord come." So that suggests doomsday, Armageddon. And that feeds right in with the blood business. So naturally people are afraid. There's even some Bible sites that I've noticed asking questions. There's one that says, "Is Jesus?" So that's what's scaring some people. And then on top of that, we've got the megamoon business. Now, the moon's orbit around Earth is an ellipse, not a circle, so the moon comes closer and farther all the time. Down low near the skyline, it always looks enormous. This is the famous rising, already eclipsed tonight, so it will be low when you see it, especially in the early parts of the eclipse. And when the moon is down low near the skyline, it always looks enormous. This is the famous moon illusion. All objects in the sky near the horizon look large. Even constellations like Orion or the Big Dipper look huge when they're low. And this is caused by the psychological effect of knowing, as we do without thinking about it, that anything near the horizon is far away. Like if we're driving and we go over a hill and there's a town in the distance and we see a church steeple in it, we'll automatically assign a size to that because we know it's far away, and we give it some perspective. When the moon is high in the sky, it's dwarfed by the emptiness of the sky. The sky is 180 degrees from horizon to horizon. It's large, and the moon is only posed earlier this year on April 15th. We had 2 last year. This is the final one in this series. So that's kind of cool, but it's not the doomsday. And we do have the harvest moon tonight that's happening at the same time. Hey, this is Slew. I'm Bob Berman, back with you live. Well, the whole thing is live. Everything we are seeing is in real time. We are watching the blood moon. We've reached hemogenesis, the start of the blood part of the moon, the red part of the moon. It looked like a black bite taken out of the moon until just a little while ago, but if you check outside your window, and you're one of the places in the world that can see this in your sky, which is not, unfortunately, Hawaii or Alaska or Asia, but it is mainland U.S., all of South America, Western Europe, and the western half of Africa. If you have clear skies, what are you waiting for? Go out, check it out. Don't be out too long, though. Stay with us because we have so much to explore. Totality is coming up now in only a little bit more than 9 minutes. And I should mention that unlike a total solar eclipse, where it happens at different times for different people around the world, because the moon's shadow then sweeps across Earth, and some parts of Earth that are going to get it will see it well underway or even see the total eclipse, while others are still waiting for it to start, and it hasn't even begun yet. Not here. With a lunar eclipse, everybody sees the same thing. It's really a unifying event. It's one of the reasons we decided to talk to the Vatican astronomer, and we'll do that a little bit later on. The Pope is visiting the U.S. So this is the kind of event that unites the world, you know, seeing this. After all, it's Earth, it's the moon, it's our planet, and so much of the world is watching this at the same time. It's really a unifying thing. We're all seeing it, and again, I'll emphasize it, we're all seeing the same thing. As long as you have the moon in your sky right now, you're seeing the exact same part of the eclipse as everybody else. The only difference is that if you happen to be standing on your head, if you're in South America, in Brazil, let's say, where the eclipse is underway, although we understand from some of our Brazil friends that it's cloudy in at least parts of Brazil, but if you're in the clear, you'll see the moon in a different orientation because you're, of course, upside down relative to people here in the northern hemisphere. So that's the only difference. But the moon, other than that, the stage of the eclipse will be identical. And as we approach totality, we want to bring back our friend Scott from the Weather Network. This is Canada's equivalent of the Weather Channel in the United States. And Scott is an expert not just on meteorology. He's been keeping it in check and hopefully keeping the clouds away when he's doing a good job of that for most of us. But Scott, we're also going to talk about these odd so-called edge effects caused by the fact that the redness is not uniform. It's odd, it's uneven, it's caused by our atmosphere. What's up with that? What's going on here?
Well, basically, the darkest part of the atmosphere, at least when you're looking at it edge on, is the lowest part, the troposphere, is that red. And as it enters the umbra and it leaves the umbra, sometimes you can catch that bluish tinge from the ozone absorption. And it's not often. It's hard to pick it out. There are pictures on the internet that people have seen, that have posted up. But yeah, this creates sort of almost like a banding around the edges of the umbra of these other colors. And if you can watch really closely, if you can get a really close picture of it, you can see that.
Okay, so for our listeners, let's translate that. Umbra means Earth's dark part of the shadow. That's the part of our shadow where no sunlight is hitting the moon. And what Scott is telling us is that our atmosphere is being bent, refracted onto the moon. Actually, what we're getting on the moon, the reddish color, is really the combination of all of Earth's sunrises and sunsets. Very lovely, poetic idea being combined into a single kind of light. And the uneven color, as he's explaining, is due to these effects. Now, as the eclipse reaches its total part, and we only have 4 minutes to go before that happens, either look outside or join us with our many feed partners and our main telescope in the Canary Islands and take a look at the color of the moon. Note how uneven it is, and this is what Scott is talking about, these different parts of the atmosphere that are throwing light onto the moon. Let's see if we can see any. He said that there's occasions when it's blue. I've never seen that in 50 years of looking at the moon. Honestly speaking, I don't think we're going to see any blue. I think any photographs of that, the web, you can show photographs of a hippopotamus flying on the web. So I wouldn't trust any colors. But let us be the observers and decide for ourselves without bias. Let's look on the moon and see what colors we see. Now, is it really the color of blood? The media is calling this a blood moon. I think you'd have to go to the emergency room if your blood ever turned this color. Scott, have you ever gotten a cut and seen your blood turn this color?
No, I haven't. It's a little bit darker than that, a lot more reddish than that coppery orangish tinge.
Good. So that's right,
Yeah.
coppery, orange, maybe yellows, there's some white there. And when we reach totality, that's 3 minutes away now. Right now we're still seeing sunlight hitting one edge of the moon. And you can look for yourself when you're outside. This looks so weird. It doesn't look like any kind of lunar phase. It doesn't look like a normal crescent moon. It looks like a little spot of sunlight, and all the rest of the moon is uneven because it's getting different degrees of depth into the umbra. The moon, in fact, in this particular eclipse, the moon is not passing centrally into Earth's shadow, but will be on the south edge of the shadow. So we expect, and correct me if I'm wrong here, Scott, that the top of the moon, the northern edge of the moon, will be the darkest. That'll be most centrally in the umbra. The bottom should be the lightest, maybe yellow, maybe different colors. Plus, it's going to change as the eclipse goes on, because once the moon is fully in our shadow, it's going to stay there for, I think, an hour and 13 minutes. So, and it's going to start 2 minutes from now. So why don't you help guide us a little bit on these final 2 minutes of sunlight? What are you seeing now that the rest of us should be paying attention to?
Well, this view of the moon from the United Kingdom is actually a really good one because it's very close up. And it's, again, really hard to see these things because, we're just looking at the contrast between the very, very bright little edge of the moon on the bottom there and the rest of it, which is getting darker. But if you really focus on the part that's right on the edge of that brightness, you can almost catch a bluish tinge. It's very hard to detect. It may even be something I'm just seeing because I've looked at other pictures and seen it.
No, I see that too. I see that too.
It's
Absolutely,
very, very faint, but it's there.
I think it's very distinct, but the question is if you were looking at the moon directly yourself or with binoculars and not using any photographic techniques, would it look blue? That would really be the question. There's not much left.
It would probably take using a telescope as they're using it here in the UK. To get a very, very close-up view of it, because otherwise it would just be too much of a contrast, too distant away to really see that for yourself just with the naked eye.
Yes. And now we've got just seconds left. The moon traveling at 2,280 miles an hour. That's several times the speed of sound. It's even faster than the Concorde used to fly. And at that orbital speed around Earth, carrying it around in 27 1/3 days roughly. It's about to pass into our shadow. Now we only have 30 seconds left, and then the eclipse will be fully immersed in our umbral shadow. And at that point, what we see is a big function of the kind of exposure that we give it. Now we have a number of feed partners along with our giant SLU telescopes. So look at this view, for example. In this view where the exposure is a little different so that you can't even see any trace of reddishness, whereas if you went outside and looked at the moon right now, I can assure you, because I just did that a few minutes ago, the moon looks red. How about you, where you are, Scott, in Canada? Do you have a moon in your sky, or is it cloudy?
Unfortunately, a lot of cloud moved into southern Ontario, and so we're only seeing it in little tiny breaks between those, and we're hoping for a slightly larger break to come in, hopefully during totality so that we can see the red moon in its full. But it's dicey at the moment, unfortunately.
And we've got it. We've diced it up. Here is, we've reached hemogenesis, the moment of the blood moon's beginning. Actually, we've been seeing it looking red, of course, as we've approached totality, but here we are. We have reached totality. Look at that yummy, scrumptious unevenness in the lighting on the moon. And this is something that is not an artifact. If you go out and think, enjoying it, seeing an effect of our own planet, casting our shadow on the moon, our one and only natural satellite. So important for life on Earth. We used to think that it was important certainly for sea life, especially the creatures that rely on the tides, the rise and fall of the oceans, especially in the intertidal marshes, crabs, animals like that. They're predators like gulls. But now we know that life itself depends on having the moon, because Earth's tilt would change radically in ways that would make Earth too hot for many hundreds of thousands of years at a time. Were it not for the moon's stabilizing effect on our tilt, keeps it from tilting more than 2 degrees more or less than its present 23.5 degrees. So this is a part of the scheme, the system, the architecture, the design, whether you believe nature itself is intelligent. I suppose you could also believe that it's all a random design. Whatever it is, we're happy for it. We're grateful that we have what we have. We're going to be seeing another viewpoint when we have an interview with the Vatican astronomer spokesperson coming up soon on the show. Hey, look at this view. This is from South Africa. One of our feed partners showing you the moon looking quite dark. I'd say it's almost a brownish red in this. Notice that the lighting on the edge is now less pronounced than it was before. We're at mid-eclipse, which means the moon is most centrally inside Earth's main shadow, the umbral shadow right now. When the exact three-dimensional plane of the sun and the Earth and the moon are in a straight line, that can next happen 6 months later. But 6 months later, the next eclipse doesn't have to be full, and usually is not. It can be a partial eclipse where the moon doesn't quite make it into the center of Earth's shadow. Or it can be a penumbral eclipse where the moon really skims the edge of the shadow. But what if you get a total eclipse again 6 months later? Well, then what about 6 months after that? Can you get another one? You can. It's rare, but you could. And then what about a fourth? That's the most you could ever get. If you do get 4 total lunar eclipses in a row, as close together as they can possibly be, that is every 6 months, that's called a tetrad. Now, there were no tetrads at all from the year 1600 to the year 1900. 3 centuries, no tetrads. So this is the 4th and final eclipse of this tetrad. So a final, and of course most important, member of the tetrad. However, just so we don't think that, again, it's Armageddon or the end of the world, because of the tick-tock motion of celestial mechanics or geometry, there are a number of tetrads in our lifetimes. In the 21st century, there are 8 sets of tetrads. So when seen in that light, tetrads are not so terribly rare. Still, it's interesting enough to deserve mention, Joe. So I thought I'd just tell you what that tetrad business is all about, and that this indeed is the 4th and final member of the tetrad. I'm going to be back again. We're going to be exploring various aspects of the eclipse. We're going to come on with other SLU astronomers. We'll have our interview and great music accompanying it. Please continue to send us hashtag SLU eclipse. Comment, ask us questions, anything about that. We'll keep watching because totality still has a while to go. This is the deepest part of it, but we're going to watch it progress. It's very active, animated, alive kind of organic thing, this eclipse. So we're here. It's 5 hours of coverage, and so we're going to continue. I'll be back with you in a little bit. For SLU, I'm Bob Berman.
a place for us to come together to share stories, photos, art, and even poetry, all surrounding the universe and our place in it. Being so close to the Earth and so much more changeable than the Sun with its many phases, changing size, and effect on the tides, and if you believe the rumors on people and animals, it's no surprise that the moon would have a place in the hearts of poets. There are plenty of songs and poems about the moon, some of which have made their way onto the Golden Record, and a couple that I want to share with you today. First up, we're probably all blessed as a brow divine, with continents of moil misery, and can immense mortality but throw so small a shade, and heaven's high human scheme be hemmed within the coasts yon arc implies? Is such the stellar gauge of earthly show, nation at war with nation, brains that teem, heroes, and women fairer than the skies? These are just a few of the many selections that you can find online, in poetry books, everywhere, of artists connecting themselves with the things they see in the night sky and expressing confusion about their own lives here on Earth with metaphor about the moon and the sun and the stars. If you know of any and you'd like to add them to the Golden Record, all SLU members are actually able to log in right now. Just go to SLU's homepage